Hi guys. Hello Joe. Hi Collins. Hi Gabriel and Osat. How you all doing?
Yeah, good evening.
Doing well,
Good evening.
Kelvin. You?
I'm doing all right, man.
Good evening, Kelvin.
That's good.
Good evening, guys.
Good evening, sir.
Good evening. Good evening. Hope we had an awesome weekend or week. Sorry, and hope our weekend is off to a good start.
Yes.
Kind of.
And you?
Well, if I'm being honest, it wasn't. It's not. My weekend isn't up to a great start, but we'll make do. Make do eventually.
That's good. That's good.
Yeah. Okay. Okay. All right. All right then. So we are going to go on with today's session. I'm trying to get my other device connected. But then how I always like to start. I want us to start from a quick recap. I think this is our fourth class, if I'm not mistaken. Right? Yeah, I think it's our fourth session. And over the past 3 weeks, we introduced cybersecurity, introduced IT. We've talked about cyber hygiene, which just gives you the generic feel and flow towards the things you need to do to be a bit more secure. Just give you that generic feel and flow. Just things you need to do to secure yourselves a bit more. And today we'll talk about operating system security. So that's what today is about. We'll talk about operating system security. I would take you through what that means, what that should look like, what it would mean to you and your team, on your as a person and as a cybersecurity expert. It also helps build that foundational knowledge on what operating system security should be or should look like. Okay, so let me join from multiple locations so I can have my lab connected as well. So today, we would touch a bit further and do like some form of, I wouldn't call it a demo because in operating systems there is what we call hardening, and that's aside from everything that we can talk about and we can try and we can do, um, hardening is one of the most important things, right? And so that's one of the things we will do. So I will show you a few things that can actually be used to help harden an infrastructure. Um, yeah. So a lot of things that can actually help harden an infrastructure, you know, and yeah. Okay, so sorry guys, just give me some time. Let me get my environment set up. Okay, so um, no, all right. So let us begin. So let me first start by sharing my screen. Let me first start by sharing my screen. Where's this screen? All right, guys. Yeah, I think I'm back now. If I may ask, is there anybody that this is their first time joining this classes or have not joined our classes in the past? Is anyone here?
Yeah, this is actually my first time.
Oh, okay. Well, that's good. It's good I asked that question.
Yeah, it's
All right, awesome, cool. Nice to meet you, Gabriel. So basically, what we did was what we usually do is
Yeah,
we just do a
sorry,
very
just
brief introduction.
I think I'm joining for the second time. I've been out of town and all that. Yeah, sorry about
Oh,
that. But
all
I've been
right.
downloading the classes and I've been like watching and yeah, trying to catch up. Yeah.
All right, cool. That's good to hear. That's good to hear. Okay, all right then. Nice to meet you all. Thank you for joining. It's good for you to try to catch up because we've basically spoken about a couple, or basically we've touched about two modules or two courses, and I believe once you have an idea of what this, get in the live class experience, and then when you now start doing your projects, it would all start making sense and it will all be a bit more exciting, right? So yeah, so let's do that. Let's get us in. Nice to meet you guys, and I hope you can really keep up with us as we go ahead, right? But then, since this is your first time, I actually encourage a lot of questions. I actually prefer when during this class students actually ask questions. Push me and say, "Oh, Miss Kevin, what does this mean? What does that mean?" It makes it's kind of like a proof that we are, the students are with me. I'm not just talking to myself, and, actually get students that are actually listening to what we are trying to do, right? So that's one of the things I like to see, okay? Yeah. So, okay, so I'm trying to get everything up and running on the side. All right, so as I said earlier, today is all about operating system security. And then this is how I always approach operating or cybersecurity in anywhere I go. What I tell people, I tell people that there are so many ways, right? So many aspects to secure your environment, right? So many things to look out for, so many places to start from. Okay. And if you neglect one of them, it's more or less like I call it focus areas. That's how I like to call it. I like calling it what I call focus areas, right? And if you don't cover those focus areas in quotes, you would find out and see yourself in a scenario where you know you would have gaps. It's basically what we refer to as gaps. When we say we do a gap assessment and say these are gaps, it's basically what we refer to as gaps. Let me give an example. And yeah, okay. Also, for those just joining, I really like using a lot of real life scenarios, to try to drive down concepts and drive down ideas, especially on this vague concepts or vague situation as cybersecurity. It helps make it make more sense, if I may say so myself. So basically, I'm trying to say that a typical example is an organization can come, right, and put a firewall. Okay, they have a firewall, and the configured firewall is so good, so it's very, very difficult to come in from the internet. But then an email was sent to one of their staff. That email contained a well-known malicious software, but because there was no email gateway security that was monitoring that malware, it didn't stop that email from coming into the mailbox. Neither did it stop that email from coming into the inbox of one of your users. Now, that's one aspect. You didn't protect your emails from known malicious software from coming in. Now, after it has come in, your staffs are also not trained to not, that they don't have the cyber hygiene, which is what we went through last week, to not click those malicious files or to not see anything suspicious in the phishing email content and avoid that phishing email content. They click it, and then that leads to a malicious software being installed on one of your computers. And then that leads to, and now the thing is, this is how it works. Let me also explain how antivirus and anti-malware solutions work. When a malware is trying to be installed, or when any new installation is happening, they scan it. And if they see that this is a recognized malicious software, they block it. So aside from even the email software, and aside from the fact that your staff is not trained, you would still see the fact that because there is no anti-malware, antivirus solution, when people click it, there is nothing that is trying to block or scan that software to ensure or cause or to prevent it from installing and causing harm to your environment. So it then eventually leads to a scenario where the hacker now has remote control of that device, and uses that device to jump from one device to another all through your network. And then what I'm saying is all the work, all the configuration done at the network layer, the edge network layer on the firewall becomes a waste because the people were focused on their firewall and didn't take any interest in the endpoints or the emails or the training of their staff. Because one of those things, if they had done it right, would have been able to, if not stop, but make it a bit more difficult. I know someone that hacked an organization from outside, like he was outside the organization, he had already found the loophole into the organization. But what happened was, while he was trying to take what we call shell, what we call shell in the hacking world is like a way to initiate a remote access through the command line, right? So while he was trying to initiate shell over the internet, something kept on disabling his shell. Anytime he wants to initiate the shell, something keeps on cutting. That was the anti-malware solution that was on the device of that server he was hacking. And so the anti-malware solution was cutting the initiation of that shell. So that's why, so even though he knows he's in, he knows how to come in, but he wasn't able to initiate and create that remote connection because an antivirus was stopping that final act. So my point is, for the scenario I painted earlier, if one or more of those things like email security, training of your staff, and endpoint security solution was implemented, the tendency of that person being hacked would have been removed or reduced. Now, it doesn't mean the person should now go and say, oh, you know what, because I wasn't able to, in quotes, protect myself from an endpoint attack, I then stop anything network, shut down my firewall and say, okay, that firewall is useless to me, and then now go and invest in buying an endpoint solution. It doesn't necessarily mean that you're safe now. Because what that means is you've opened your entire network to a lot more attack. So if that anti-malware is stopping some attacks, there are some attacks it won't stop. And it will be easy for the people to try because there is nothing stopping them through the internet. So these are some of the things that you don't want to say, okay, so how do we go about securing an environment? It's by looking at it scope to scope. Now, today, we are talking about the scope of operating systems. That is the softwares that drive our computing use. How do we ensure these devices or these systems or this software is secure, or at least is trying to be secure? That's the conversation for today. That's what we're trying to discuss today, right? So I don't know if anybody has any questions so far before we dive deep.
Everything seems clear to me.
Awesome, great. So so on that note, I will go through the slide. As I said, can someone please confirm if my slide is clear? Because I'm not too sure. So can you all see my screen?
Yeah.
Oh,
Can see it.
oh, awesome.
I can see it.
Yeah, I can
Great.
see. I can
All
see.
right. Thank you so much, guys. Thank you. Okay, so operating systems and security course. But before we go ahead, can I be allowed to just go get a quick coffee? Just give me a second. Let me get myself coffee and then. Okay. All right, guys. Sorry for the break. I am back. Okay. All right. So as I was saying, the first thing we'll talk about in operating systems and security is, first of all, we want to define operating systems. What are they? What's their purpose? Then look at the common functionalities that come with operating systems. Look at a brief overview of different types of operating systems, right? Understand the differences between desktop server and mobile operating systems, because these operating systems are actually different. And so, they're built in a different way with different targets and purposes. And, and then we'll look at the basic components of an operating system and then understand how the interaction of the hardware and software layers of an operating systems, how it works and how operating systems come to play in that role. So, because first of all, I always tell people, and I've said this before, you can't really put up what you do not understand. And this is where it starts. You have to understand operating systems. You have to understand how it works, what it actually is doing. Okay. So yeah, so that's what that is. Okay, so then, as I said, Awesome. So as I said, first of all, what's an operating system? Now, an operating system is the interface between the computer hardware and the user. Now, we can think of it in so many ways. We can imagine or consider quite a whole lot of things when we talk about operating systems, but I know one of the things I always like telling people is how the Windows operating system revolutionized computing, created the concept of personal computers. Back then, when computers were a big deal, or when computers were just starting, a lot of people would need to have some basic understanding of computers. I think there was even a time where to interact with a computer, you have to understand a certain kind of language. The fact the computer literacy training was a big deal then. If you can use computers, you were a hot thing, right? You could fly up in your current role and become like one of the most important staff in the entire organization if you know how to use computers pretty well. And then back then, even if I think there was a time when if you could type using a typewriter, you were still a big deal. So these things were um the level of computing back then. And then Bill Gates came with the Windows computing operating systems, which made it very easy for anybody, those without even putting much effort, to be able to use a computer. And that was how it all started. And so it's so all forms of operating systems are some form of interface between the hardware and the user. Because, for example, we want to use computers for a reason. It's not just as if we like pressing computers. There is something, for example, we're using like right now, we are using all our computing devices, both mobile devices and laptops, for a virtual class, a virtual session. The purpose of that activity is virtual session, right? And a lot of things are involved in that virtual session to happen. Can someone here tell me like one thing that the things is involved for this network session to exist? Anything at all? What do you think is involved to ensure that this session we're having is happening? Anybody?
Networking.
Exactly.
Network is
Networking?
bad.
Yeah, networking. Exactly. Okay, what else? What else? Any other person? Network is
Hardware.
one. Hardware. Awesome. Perfect. All right. Any other person?
Application.
Application. Good. Who here has noticed that Joe just mentioned the three components of IT that we said in the first class we had? But yeah, yeah, totally correct. But is there any other thing in particular, that you might want to say, that made this happen? Is there any other thing, or those three is enough?
Internet.
Well, internet and networks are the same. So I wanted you to be like a bit specific. So, for example, I'm saying we're having this meeting over Microsoft Teams,
Operating
right? So we
system.
talk about operating system. God bless you. The operating system that allows us to connect. The Microsoft Teams application we're using, even though that application just fills the whole thing, but I wanted us to be a bit more specific. The Microsoft Teams application, right? The operating system that we are working with to achieve this. The network devices that we are connected to, the ISP that we are connected to, and the network devices in the ISP's network that is taking us out to the internet, right? All those things is what make this happen. But one of the most important as well, even though it is in the operating system is in the part of software and applications, but it's one of the most important. The reason is it is the guy that brought all these resources that we need to connect to this meeting together. It's the guy that brought the computing processing power of our computers or our laptops or our devices or our phones, because that's needed for us to be able to process all this information. Because we are talking about we are processing live traffic in real time. So the computing power, the processing power required to do this is the operating system that brings it all together. The hardware that it is all built on top. The operating system is one that ensures the hardware is doing what's expected of it. Remember, if you talk about network, as I said, there's always some form of connectivity. For example, I'm connected through my Wi-Fi. meaning that my Wi-Fi network adapter on my computer is connected to the wireless network in my house. So if you put one and two together, what that means is the operating system is the one that brings all the processing power and all the hardware and all the software and all the requirements, like all the instructions. For example, when the network device connects to the wireless network, where exactly is it taking us to? Where is it? What's it requesting for? Operating system is one that brings in all this information together. The network card, the laptop, the software, all those things together. Because if not, what exactly is the message that is going to be sent through the network interface card from our computer to the receiving end? What exactly is the conversation going to be about? And that's what operating system is very important because it shows that synergy. Okay, it shows that synergy. All right. So, as I said, operating system is a program that manages the computer's hardware. It also provides a basis for application programs and acts as an intermediary between the computer user and computer hardware. That is an operating system. Okay. Yeah. Now, as I said, the task, one of the most important tasks of an operating system, is that it carries out its allocation of resources and services, like allocation of memory, allocation of processing power, allocation of devices, allocation of processors. Where is information going to? Direction, instruction. That's one of the major things you see that happen with an operating system. And that's why it is very key. It will also include programs to manage these resources, such as traffic controller, a scheduler, a memory management module, input output programs. Who recalls the input output devices that were taught back then in secondary school? Can someone, in fact, can someone name me one input device? Anybody, just name me any input device you know in a computing system.
Headphones,
The flash drive.
Headphones, flash drive, okay. Headphones input, yes. Not the
Mouse.
mic. Mouse, yes. Flash drive, not
Mouse.
necessarily. Mouse, yes. What else?
a keyboard,
Yes,
Keyboard.
keyboard, yes. Yes, keyboard, yes.
Okay.
What else? Any other one?
monitors.
Nope.
Mouse.
Monitors are not.
No.
Mouse.
I think someone has already mentioned mouse. Okay, well that's actually most of it.
CD-ROM, CD drives.
Mm, are
No.
those input devices? I think they're more or less outputs, right? I wouldn't say. Maybe,
What of an
maybe.
external hard drive?
Um, is it an
Mouse.
input device?
Microphone. Mic.
Mic, exactly. Mic. Someone said headphones, but mic as well. Exactly. The mic, exactly. Well, I do think we have quite enough, right? Now, what about output devices? Someone should give me like just want like 3 output devices.
Monitor. Monitor.
Monitor. Okay.
LAN cables.
Hmm.
Webcam,
Speaker.
I'm not sure about long cables. So sorry, what did this guy say now? Who said what now? I heard something.
webcam,
Webcam.
Speaker.
Ooh, speaker, yes, speaker.
Speaker.
Webcam, I think webcam is
Monitor.
even more inputs than output. Yes, we already said monitor, we said speaker, yes, speaker, I agree, monitor, I agree. Any one more output device?
Wi-Fi.
Printer. Printer.
Huh? Printer,
Printer.
yes, printer, thank you. Yes, printer, you're completely accurate. Printer is an output. That's fine, that's fine. So it's all good, guys. It's all good. I think we have enough, right? Why I asked that question is I'm trying to let us understand that there are some input and output devices in terms of the communication between that input and output, the guy that takes it in and the guy that takes it out. And the guy that, you know, brings all those things together, the one that takes in the input, processes the input, and helps push the output. Operating system is in charge of all that. That's how it works, and that's the importance of it. And that's why sometimes you might see that you might, if let's say if you get a new keyboard or this external keyboard, you might tell you install a driver. Has anyone ever experienced that thing?
Yes, yes.
That driver, what do you think it's doing? The driver's job is to ensure that the new device that is being plugged in can communicate effectively with the operating system. You get it? So that is how important the operating systems are. And I think it's very clear because it is the base of software. So every other thing about that computing service is as good as done without an operating system. Even network devices, storage devices, most of them have their own operating systems. Even though the operating systems are not like graphical, like how we experience with Mac and Windows, but they have some form of system that runs on top of their hardware. So that is how, it is. Now, if we then come and talk about, right, now, if we then talk about the common functionalities of an operating system, we have the likes of memory management. That you're saying, okay, you need to manage memory. You need to allocate the memory of certain process, or for a certain process, not of for a certain process. That is memory management. We also have the likes of processor. Is one of the major functionalities of an operating system. The processor is usually in or worked with or part of an operating system. So it's one of its functionalities. The one other functionality is devices. I already mentioned input-output devices. Another functionality is managing files, opening, downloading, creating of files. Happens to the operating system. Also, another one is user interface and command interpreter. Now, an operating system does the work of translating complex things that are happening, in the back end, behind the scene, making it much more exciting, making it easy for us to use it. Do you know that every button click is a program you are using? Yes, every button click. And now those things, those day in, day out conversations, those integrations, right? It's a lot of work on the back end. So operating systems help provide this flair of, um, it helps provide this form of ease. That's the word I was looking for. Ease while using the system. Okay. Now we also have the likes of booting. Operating system helps you drive booting. Where are you booting? When you turn your computer is meant to boot. Where and what are you booting to? Okay. Then we also have security. Some common functionality of an operating system is that it helps manage the security of some areas. Be the one in charge of, okay, this is how the thing works, this is how it works. But it gives you that freedom, to define the kind of security you want to enforce at his own level. Then you have the network management, which is also another thing that operating systems would help you manage your network usage. Okay, so these are some of the common in keyword common functionality of an operating system. Okay. Please, as I said, if you ever have any question, I really, really appreciate someone to reach out and ask me those questions. It makes me sure that we are all together in this class. Okay. Now, different types of operating systems. Now, I know people will be expecting to see Windows, Linux, Mac. Well, these are different ways operating systems can work or function. All right. Now, operating systems can function or work in a batch mode, batch processing operating systems. It can also function with a multi-programming um, multi-programming operating systems. It can also work with time-sharing operating systems. It also works with um, network operating systems, right? So that is, um, you know, the different ways or different types of what's it called? Operating systems functions. How does it function? How do they work? Who do they connect to and what they connect to, right? All those questions can be answered. Right. So yeah, different types of operating systems are there. So I give an example of
Sorry.
network operating systems. Yes, please. Questions?
You said this different type of operating system functions, or just different type of operating systems?
More or less functions, right? Because if you had used different types of operating systems, you're hearing things like MacBook, Linux, Windows, right?
Exactly.
Yeah. So it's more or less functions, how it works, what it does, what it's being used for. So there are some operating systems that are used to process batch processing. That's when there's a requirement for large computing processing requirements in batches. So some operating systems are built for this purpose. Some operating systems are built for multi-programming purpose. That is a multi-world, right? Some operating systems are built for time sharing, while some are built for networks. Some are built for real time. That is, you want to design or implement a real-time monitoring system, right? You have those built for that as well. That is how operating systems are built. Okay.
Yeah.
Yeah. Thank you. Nicholas, I didn't want to ask questions.
Yeah,
I think I saw
yeah,
your hand
yes,
up.
yes, yeah. So
Okay.
I'm just thinking, instead of using different types of operating system, why not we change it to? I'm just thinking to
Yeah.
functions or like
Yes, of
functions
an
of
operating
operating or
system.
different
Okay.
functions of operating system, so that we don't get, because the truth be told,
Please.
you can set an exam now, you put different types of operating system. I will tell you Linux, and you understand what I'm saying, without adding
I do.
functions to it. Yeah.
I do. So yes, I get your point. So the thing is, what we use to this, so it still stays as different types of operating systems, right? But what we use to explain those things we call it examples, right? It's an example of an operating system. You understand me? So because there can be multiple examples. For example, Windows and Linux and Mac OS are user operating systems. Their type is a user, I think, multi-programming operating systems. But Cisco iOS that is used for network devices, Huawei AIX and a few other ones, those ones you call them network operating systems. The ones that I use, I think Digby or whatever that is used for IoT, Internet of Things, those ones you call them real-time types, and there'll be examples of a real-time operating system. Do you understand? So for this purpose of this course, it splits in. We have different types of operating systems and examples of operating systems. Does that make more sense?
Yeah, yeah, yeah.
Exactly.
Thank you.
Awesome. So yeah, so I guess on that note, I will go into the examples of what are examples of operating systems. Well, I put the three most important ones: Windows, Linux, and Mac. Windows, Linux, and Mac. These are the three major types of operating systems we have. Oh, sorry, I think I've just found out that my video was off all along. Okay, sorry, let me just turn that back on. Yeah. All right, so as I said, Windows, Linux, and Mac are kind of like the three major, most popular operating systems. And if you even do your research a lot, you find out that Linux operating systems, they have a lot of spin-offs because Linux operating systems are open source. Right? It's an open source operating system based off of the AIX, I think AIX, yeah, AIX standard. So, right? So, meaning that what it happens is a lot of people have built their own flavor of the Linux operating system. There is the Ubuntu operating system, there is the Solaris, there is the Kali Linux, there is the Parrot Security Linux, there is the basically quite a lot of Linux distributions or Linux flavors, right? So it's just for you to find out, okay, which is fine with me and which, um, the one that would actually be very good, to fit your needs. For example, Kali Linux is an operating system for ethical hackers. If you're not an ethical hacker, why are you getting a Kali Linux, for example, right? It doesn't have value. Do you understand? Exactly. So that's how it works. All right. Good. Now, so these are some of the examples of operating systems. Now, if we go again, I want to do a very brief comparison of different operating systems that have existed. And if you can see it very well, you see all the different examples of um, um, the number of the operating systems that are in scope. Likes of Kali Linux, likes of Ubuntu Linux, likes of Red Hat Linux. In fact, already there's like 3 different Linux operating systems. Then we also have the likes of Mac OS. We also like likes of Windows Server operating system. Now, so what are the variations of versions, or what are the differences? Brief comparisons. One, Windows 10 is a client operating system. Now, do you know what a client operating system is? Or do you know what a client, in fact, we here can break down the client server approach to me. Yes, sounds right.
Is the one that is. Go ahead.
Sorry, come again. Hello, are you still there?
No, Joe, go ahead. I wanted to say something before. Like,
Okay, anyone then? Is there anyone?
so my own thinking there.
Okay.
Say Windows 10, when you say it's client based, like it's an operating system that enables you or allows you to um put whatever it is that you want to put on that operating system, tons of applications, softwares, and you are the one that has what it takes to manage those that operating system. Yeah. So just it's a regular user thing. My thinking. Yeah.
Okay. Yeah, that's a good way to look at it. Regular user thing. Yeah, that's actually very, very good way to look at it. So I think what I wanted to hear, what I was hoping to hear, was someone would actually show me the relationship between clients and servers. Now, clients are user computers, you and I, the computers we're connected to right now as a client device. Now, servers are the services they hit anytime they connect to anything around the world. Any server they hit, right, is a server. A server serves you or people with send information or send data, and it will be sent from the client to the server or the server to the client. Okay. So now some of the big differences, as I said, Windows 10 is just a client machine. Windows 10 is also for regular users. Windows Server. So Windows Server is actually obviously a server machine, and then it is actually for administrators. Red Hat Linux is also a server machine or operating system, and usually and it's very what's the word? Very highly rated. The Red Hat Linux. In fact, I tell people that if you can on your own become a full administrator, if you can single-handedly manage that whole massive requirement, because I have to say, the Red Hat Linux is not like normal. Red Hat Linux is like normal Windows server. It's very massive. it's the kind of operating system that houses and takes responsibility of a country's infrastructure or of a big organization infrastructure and doesn't even flinch. That is what Red Hat Linux is built for. That's why it's called Red Hat Enterprise Linux. It was built for big organizations to use them and set up the core services they want to deliver. RHEL, very highly regarded. Then we also have the Ubuntu, is also from form of Linux, right? And then uh, um, so I'm trying to tell you that the Ubuntu actually has a desktop and a server version, right? So the desktop version is what we're talking about, and the Ubuntu desktop, all right, it sort of helps you, it helps you to, it's like a way to set up your own lab. I think that's the best way to put it. And then the Ubuntu is quite, useful and really nice. And it's a client-side device, so as I said, it's very good for testing, very good for implementing stuff, just to see how it will work in the real world, right? That's the importance of Ubuntu. Now, we also have the Mac OS, which is, obviously everybody knows, it's for regular users, and it can be used for also, this is where the Mac OS tries to beat, um, um, the thing is, a lot of people, a lot of services, a lot of um, activities are happening. You would see that the Ubuntu Linux and on the Mac OS Linux, and so on the Mac OS, sorry, it gives options for both a regular user and a power user. Why do we talk about power user? A user with a higher level of control. All right, that's the idea around it. Okay, so that is a brief comparison, a legitimate brief comparison of it's the it's one of the things that you need to understand, probably, especially if someone wants to um, make a decision on the different OSs you can go about it, right? So there are different OS comparisons that you can look at. Okay. Now, basic components of operating system. What are the basic components of an operating system? A very vital question. Now, the basic component of an operating system is the kernel, the shell, and the file system. Now, the kernel, shell, and file systems. Now, what are they? Now, the kernel is like, how will I put it? It's more or less like the back end device. All right. The kernel is like the back end device of an operating system. Okay. All right. So it is one of the central components that helps manage operations of computer and hardware. So it is the core of that operating system, and it will help take over or help control over almost everything in the system. It's responsible for preventing and mitigating conflicts between processes. It's basically the guy that manages computer processes inside the operating system, right? So he's very key. And so, same as the shell. Now, this guy is who we call the command line interpreter. It allows our users control their systems. Okay. So it exposes the operating system services to a human user or other programs. That is the shell. So as I said, the kernel is the base part, the main part, the one that is in charge of managing all the processes that the operating system wants to manage. Right now, a shell in this scenario, in this case, now stands for the shell. In this case, would now stand for what's the word? So that's trying to look for the word, but I can't find it. But point is, a shell and a kernel are very two different things. How is the kernel is focused on the core service of the operating systems, filling the assigning tasks, managing processes, and the rest. While the shell is the one that helps manage the user interface of that operating system. And then the file system is managing all created files of the operating systems. Right? So that is how it works. That is how it works. Okay. So there are three major components: the kernel, shell, and file systems. Simply put. Okay. Great. So before we go any further, I would like to hear from you guys. Do you have any questions about operating systems? And what do you think we can do to protect them as we talk about a lot of things about it? What do you think would make sense when we say, okay, we want to protect our operating system? And we see this and be like, oh, yeah, you guys tried. What are the things you think we can do in protecting our operating systems? As so far as I've said a lot of things, quite a lot of things about what operating systems do, how they work, what do you think we can do to protect operating systems?
Your constant updating of your softwares. I think with also having antivirus. I think. I don't know if I'm right.
Okay, that's a good way to think
Updating
about it.
the patches.
Okay, upgrading patches. Yes, that's a good way to look at it. Upgrading patches, perfect. That's actually a good point of view. What else? What else?
Can I say vulnerability scanning?
Well, it it is a good thing to talk about because it's more or less a concept. So yes, I'll take it, even though it's beyond operating system. But then I'll take it. I'll take it. Any other thing? Is there any other person that has any addition? Well, we are all right though. There's no one that has been wrong. Actually, we are all completely accurate, right? Yes, that is how operating systems work. Right? Operating systems have, I've just been talking about a lot of things about operating systems, the components, how it works, how it communicates, and be asking, okay, so how do we now protect this operating system? So that's it. So we are thinking, because all this we're talking about how do we protect it? Okay, so yes, everything you guys have said so far is completely accurate. There was no one here that was wrong, right? So yeah, we are still on the right track. All right. So let's just move ahead then. Now, I mentioned that we have desktop operating systems, we have server operating systems, and we have mobile operating systems. Now, remember when I was mentioning and talking about, I was saying that we would look at some of them. All right. I was saying we would look at some of them because we need to understand what they do and what are the differences between desktop, a server, and a mobile operating system. Okay, so in this case, so in this case, yes. Hello. Sorry, I'm a bit lost. I heard someone speak. I don't know if it was a mistake.
I keep on like, no, they work for this.
Oh, Gabriel. Okay, I think maybe I need to mute Gabriel.
I talk to this man. Hello, good
Hello,
evening,
Gabriel.
sir.
Hello, Gabriel. Are you here? Okay, just muted. Thanks. All right. So, as I was saying, so in the operating systems, right, we have, if we can look at it from the angle of the three major types of operating systems, we have mobile operating systems, desktop, and server. We'll talk about, first of all, we'll define it. We'll talk about, okay, what is their memory requirements? What does it look like? Then, what's the storage requirements? How long does it take to boot on a good day? And what's the purpose, I'm pretty sure everyone here already has an idea of this thing, but we'll just talk about the bit. So, mobile operating systems, these are types of operating systems that allow application software to operate on mobile devices, right? As I said, these are the ones that they basically do what we do on our computers to our mobile phones. That's the mobile operating systems. Now, their mobile requirements are quite minimal, because they don't really do much, right? So there were times where, if I remember back then in school, I used to have an Android mobile device that actually had 512 megabytes RAM. Yes, I used one Android device with a 512 megabyte RAM. It's so funny how time flies, right? But yeah, I remember that I did use such devices back then. Okay. But as I said, the requirements for a mobile phone is not really that much because the expected work isn't as much, right? So a minimum RAM is required. It uses flash drive to store the data. Now, what I mean when someone says flash drive, they mean data that is fast. Data that help you reach your data quickly. Okay, so it's a type of hard disk or drive that helps speed that connectivity or that responsibility of connection, to pick your data. And booting time, it takes way less time than any of the other two operating systems, and it handles cellular and wireless connectivity and device access. Very important to hear the cellular part because the mobile devices were built for cellular conversation. So it was part of the part of what you're trying to achieve, right? There is the purpose is always very neat. It needs to be clear, So as I said, mobile operating systems were built for cellular conversation. That's a part of the purpose. Okay. Now, desktop operating system is the one that helps manage a user's environment, especially on a personal computer. Now, it's recommended that it should use huge memory to operate. Huge memory is like between 4 to 16 gig of memory, right? It also uses hard drives and flash drives for data storage. It takes more time than the mobile operating system to boot, and then it handles software and hardware like an option, like very closely, very, 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 very closely, right? Now, then we then have our desktop server operating, more or less, um, more or less looking for how to explain the server operating system. Okay, beautiful. So remember how we talked about clients and server side? The server operating system is what drives those server side computing devices. Right now, it's an operating system that is designed to install on users or to be used as a server computer. Now, usually a minimum of 12 gig is expected, but sometimes even 16 gig is not enough drive a server. So it's usually recommended of 30 gigs and above. Now, also, there are 4 server storage types that can be attached to the servers. Now, there is the direct attached storage, that's the one that is attached inside the storage directly. There is the network attached storage, the one that is connected through the network. There is the storage area networks, that is a lot of storage devices connected together, and you're giving to a lot of um, um, computers or servers to push their storage there. And then the cloud storage is also there. So all of these are different types or different scenarios or different situations uh, for you know for how understanding getting the difference between all of them, all being same types. Now, obviously, it takes much longer than the other two. It take much longer than the other two, and then we offer advanced capabilities to run, manage, monitor, and control applications, processes, and client devices. Right now, this is some of the things I also want to talk about. So, just to speed up a bit, features. Okay, so there's still power. For the power, mobile operating systems are optimized. Now, for desktop, for the power part, um, it's not as optimized as mobile operating systems to prevent energy loss. And for servers operating system, it has about 200 watts to 1.5 kilowatts power. Got to. All right. It has about 200 to 1.5 kilowatts gotten for the server operating system power required. So meaning that the server operating system consumes much power. The server operating system consumes much power. That's what the basically is saying. It consumes much more power. Right. So it's basically just, as I said, this is things we already know. It's just trying to explain this a bit further. Interface, communication interface, that basically the input communication is based on for mobile operating systems or mobile phones these days use touchpad devices, touch screen devices, right? Um, for for desktop operating systems, we usually run through many input devices, mouse, keyboard. We already mentioned a few of them, mic, and a lot of things like that. Then server operating systems can be accessed through a few user interfaces, like the command line interface, like I've been talking about, and then the graphical user interface. Okay. Now, it allows remote connection through other client devices as well, depending. Now, some of the examples of mobile operating systems, Apple, Google, Bada, Palm, Symbian. I remember Symbian operating systems then. And it's so funny how life changes. I remember when Symbian was a big deal, but then we stopped seeing devices with Symbian operating systems. Windows Mobile OS, BlackBerry, iPhone is iOS, Harmony operating system, WebOS. There are quite a lot of them. Now, what about the desktop operating system? We have Windows, Mac OS, Windows Vista, Chrome OS, Ubuntu, Kali Linux. Server operating systems instead, we have likes of Red Hat Linux, Windows Server, Solaris OS, Debian, Unix, CentOS, Linux, and the rest. So yeah, there are quite a few operating system examples here. All right. So I wanted to we'll round off with the interaction between hardware and software, and then I wanted to show us a few demo on setting up a virtual machine, showing you how virtual machines look and work. I really hope I now have access to share my screen on my other device because it will really help if you can see it. Showing us how virtual machines run, what it looks like, and maybe then hoping I can show you um, uh, hoping I can show you what's it called, a simple taste of what operating system hardening could look like, because our next class we are going to work on operating systems hardening your operating systems, right? So yeah, that's some of the interaction between software and hardware layers that we might want to look at. All right. So now, so on the interaction of hardware and software layers, we have the human users, you and I. What we're currently doing, we're using our operating systems, our computers. Now, we communicate directly with operating systems, and sometimes, or most times, we communicate with communicate with the application that's communicating with the operating systems. So sometimes we're on the Windows operating system directly, probably on the desktop or on the Windows folders, and playing around it. And then most times we are actually connected to an application, probably running the maybe Microsoft Word application. We are on a PowerPoint application. It could also be what's it called? Just any application you can think of. The Google Chrome, your browser applications, they're all forms of applications, right? You could be running those applications, and that's where your that's the bridge between the communication between you and the operating system. So it's not every time you're directly hitting the operating system. Sometimes you're hitting an application that you're hitting the operating system. And now these operating systems now, it has a hardware that's communicating with it. But then there are also some middleware. Now, middleware are kind of those softwares that are in between the operating systems and the hardware. They help to necessitate and energize that communication that you might not even see. It helps ensure that there is a smooth running of different layers. Right? That's how it works. So that's one of the major interactions or major things on how major architecture behind how operating systems and the hardware and the software work, and how operating systems is the glue between the hardware services and the software services, of any device, really. Okay. Now, to round it off a bit, we'll talk about process management. In operating system, a process is the unit of resource ownership and data protection, and a thread is the unit of dispatching. As an independent, lightweight process, threads have accounting and control data related to them. Operating systems maintain thread control block for each thread. Now, this is just a simple explanation of how operating systems manage processes. A process is initiated, they are going to have a thread for it and able to maintain that TCB, which is a thread control block for each thread, tracking each process and giving the right resources to each of them. Because process management is referring to the activities that would help you manage the execution of multiple processes in an operating system. It includes creating, scheduling, and terminating processes, and as well as helping enable that whole process conversation, really. So that's what process management really is. And I want to see if I can show you a couple of things on the setup. Okay. So let me try to share my screen again. And let me know if you can see it over. So that my camera is not the best position. Okay, so let's see. Okay, so let me know if you ever see the screen I share. Yeah, so remember this decision, entire screen. Let me know if you can see my screen, please.
Yes, I can see it.
Oh, really? Awesome.
Sure,
So,
sure. I can see us.
oh, okay. So basically, what are you seeing now?
It's you that we are seeing. No, we are not seeing your screen.
Okay, not your screen. Sorry. It's not
Oh,
screen.
I'm talking of the screen. I'm
We,
sharing
we
a
can't
screen
see
with the
what you're
VM.
sharing yet. No, we can't see it
That's
yet.
that's what I was asking. Okay, just give me a second. Let me look for it. Download. Okay. Okay. Yeah. Just give me a second. Let me see if I can quickly get this sorted out. Right. Okay, so in the meantime, I remember when we were talking about how to protect your operating system, right? Now, we spoke about a few things. Okay, but then we've not really spoken about, we spoke about antivirus and endpoint solutions, but in the world we are now, because of the ever-changing world, antiviruses are no longer in use. That's the simple truth. Antiviruses are not enough anymore, right? Sometimes people still feel, oh, we can use antivirus to do work, but tell for a fact that a lot of people are not really feeling that same confidence in antivirus solutions. They are more focused and concerned or controlled about anti-malware or some form of endpoint detection and response, something that has this constant what's the word? Adjustment, or basically real life effects in terms of security in your environment. So in the protection aspect of it, you know, it's good to note, right? It would be good to note that it's no longer about just hardening. Or let me just give you a bit of tips. I don't know if you guys have ever heard of the CIS benchmark. Obviously none. Not. Now, in cybersecurity, let me tell you what organizations that really know what they need to do have to start doing. Instead of throwing money away and spending, when you want to secure, the first thing you do is ensure you harden. We call it hardening. We will still get to that and we'll actually talk about it in detail, in the probably next week in our next session. But it's called hardening an operating system. Ensuring that the operating system has the basic expectations in terms of enforcing the security. Who here can remind me of one of the number one rules when talking about security? Can anybody remind me? Like what I always say that is like an unspoken rule in security in general. Who here remembers?
Cryptography? Cryptography?
Nope.
No.
Nope. Any other person?
Is it that there's no 100% security?
Yes. Thank you, Collins. There is no 100% security. Yes, that's the unspoken rule. There is no 100% security. So when we talk about hardening an operating system, it's about making the operating system pretty difficult to crack. Do you get it? Making it something that will be hard to break down, really. So what that means is, uh, okay, sorry, just give me a second. Let me. Uh, so what that means is the hardening actually helps you and helps the team. So yeah, so I was saying that the hardening actually helps you try to input, or I won't say use what input, but create that scenario, right? Help that whole process. Okay, that's what that helps you do. So what it's saying, or what I'm trying to explain in there is, you have. Okay, I think my lightning is back up now. Yeah. So what I'm trying to explain there is, you have um sorry, you have you have your the basic processes, right? You have what's expected of you. You have the okay, so I'm trying to enforce security on this. I'm trying to make my environment a bit more secure. I'm trying to make my environment very resilient, right? Now, what we are trying to achieve is people to not hack us. Now, when you harden your operating system, you've already done the basic control first. It's like I'm starting here. You understand? It's like I'm starting here. That's what it's like. It's like, okay, you know what? We are going to start from the base issue, the base problem. That is how that's the message I'm trying to pass across when talking about the hardening. So if I harden my computer and uh, the basic flaws that you might see, we've eliminated it. Let's say, for example, let me give an example. There is this service called SMB signing. You can Google it right now. It's called SMB signing, and it comes with every Windows device. Okay. Do you know that that service is built and is created to actually help them try that enables remote connection with Windows devices? And people have taken advantage of that service to exploit a lot of Windows devices. In fact, is anybody here connected with the Windows device? I want to show you something because I'm not connected. And my Windows device is not here yet. Does anybody here connected with the Windows device?
No, I'm not.
Anyone? If you have in this device, please let us know.
No, I'm not.
Really? So I trying
I
to say that
guess
everybody here connected
I
with their
guess
phone,
everyone is using Mac.
or we connected with our phones?
No, I'm working, so I'm using my phone. If I was at home, I would use a Windows. Yeah,
Oh, okay, yeah,
yeah.
that makes more sense. All right, that's understandable. That's fine.
I have a Mac system close to me. I can put it on. I'm a Windows system close to me. I can put it on. Is that fine?
Yes, please. Yes, please. While I'm trying to see if I can show you one.
Okay.
I want to show us something. Let me see if I can show this. Sorry, I'm also trying to see if I can have sub browsers. Let me try the Brave browser there. All right. So I wanted you to do something. I wanted you to type help in your search box.
Okay.
Let's type help. Yeah. You come in. While I'm trying to figure out this guy.
Help, right?
Yeah, help in your search box.
Yeah.
Not in the folder, on the Windows search. No, on the
Yeah.
Windows
That's right.
search.
That's
Yeah,
where it
and what
went
did you
to.
see? And
It's loading. This is
what
what it
did you
brought
see?
up. Is it? Let's help you get connected.
Okay. Is it showing you, is it telling you to provide or is it telling you to give someone remote access to your computer
Yeah, I
to
think it
help you?
said the thing is showing there's a something I tried to fix. Restart the Wi-Fi network adapter. I think something like that.
Oh no, that's not what I wanted us to do. Don't worry. Let me see if I can quickly connect with my Brave browser. Sorry, I don't know if because I'm thinking
What's up?
so I'm able to share my screen. Yeah, thanks, Nicholas. That was helpful.
Okay.
Okay, so okay, so let me see. Let me get it. Let me see if I can join in my Brave browser. And so let me show you this. If it would allow me to connect. Share my screen as well. So okay, this is more like it. Okay. Okay, so let's see if I'm able to join share screens here. This looks more like it. This looks more like it. Yep. Let me know if you see my screen now. Do you all see my screen? Oh, awesome. Great. All right. So this is what I wanted to show. Guys, this is what I wanted to show. Okay, so I want to before I do this, let me go to my Windows 10 and get it up. Let me open my Windows 10 virtual machine. Okay, so first of all, I know we in our last, I think our second class, if I'm not mistaken, I spoke about virtualization to you guys, but I didn't show you anything, right? Now this is, who here remembers what I explained and called a hypervisor? Can anybody tell me what I called a hypervisor? For those that were in the class and those that have watched the recordings, what is a hypervisor? Hmm? Anybody?
I I think during that period you were saying something that it enables you create another window on another existing window, more like without having to tamper with whatever it is that you already have. If I'm
Window?
right.
Why
Yeah.
using the words window? Why are you using the words window?
Okay, like an operating system on another operating system
Okay.
without having to affect what you like the other one, the virtual one not affecting the existing one. Yeah. So
Yeah,
you can delete it and you can make any changes you want to do without it affecting the origin, the host. Yeah.
yes. That was when I was explaining virtualization, but that's not a hypervisor. I'm calling. I saw your hands up.
Can I chip in?
Oh
Can
yeah,
I chip in?
yeah, yeah. Joe, you
Yeah,
can. Okay, go ahead, Joe.
hypervisor helps you run multiple servers.
Service. I actually want to use the word service.
Oh no, let's say operating systems helps you run on a single computer.
Yeah, yeah. That's the way to look at it. That's the way to look at it. Yeah, I would accept that. Collins, your hands were up before, and you dropped them.
Okay. In simple terms, I asked you if you need like a software to set up a virtual machine, and you said yes. So
Mm-hmm.
from my own perspective, I think hypervisor is what you use to set up your virtual machine.
God bless you. Exactly. You're right. Joe as well. You're right, and that's it. Um, that's what it is. It is a platform that is used to manage, create, manage, administer, support virtual machines, right? And virtualization. So I mentioned that there are two types of hypervisors, type 1 and type 2. Who can tell me the difference between type 1 and type 2 hypervisor? If you really listen, you should be getting this. I'm waiting, guys. Type 1 and type 2 hypervisors. What's the difference? This was something we did 2 weeks ago, so. Waiting. Yes, Osas.
Yeah, I think type 1 hypervisor is used for empty system. A system
Empty
that is
systems.
empty,
Okay.
not
Yeah.
that is not nothing that is that is not pre-installed, no pre-installation.
Good. Yes, I like that.
Why
Yes, thank you.
why type 2 is already an installed system that has existing program running on it.
Beautiful. Yeah, I would have loved for you to just use the word operating system. That's an existing operating system running on it.
Operating
But
system.
yes, you are
Okay.
completely accurate.
Yeah.
That's the difference, right? Type 1 is the one they call bare metal that is installed on a completely empty hardware. The hardware has no OS on it, no operating system on it. It's just empty. I install a Type 1 hypervisor and you run. While a Type 2 hypervisor is installed on an existing a machine that has an operating system set up and fully configured. You get it? So yeah, you're completely accurate, Osas. Thank you for that. Now, let's look at my screen, right? I hope you guys can still see the screen, I'm sure.
Yes.
Awesome. Now, I'm running, my computer is based on a Linux machine. And I'm running a Parrot Linux machine. It's also a security related Linux machine. It's just like Kali Linux, built for cybersecurity activities, right? Now, that's my Linux machine. Now, on this Linux machine, I have on this Linux machine, I have an application that I call VirtualBox. Now, this VirtualBox, is it a Hyper-V? Is it a Type 1 hypervisor or Type 2 hypervisor?
Type 2.
Type 2. Thank you. Appreciate it. How about this VMware that I'm running here? What would you call that? Anybody? What happens? The VMware is what?
I think it's type 1
Why are you say Type 1?
because you have to put the stuff inside. Like when you're writing your code, you have to put it in or doing.
What's the difference between Type 1 and Type 2 again? Can you remember?
Yes.
It was okay. So what is it? Type 1 or Type 2? Okay, so let me answer the question. It's actually Type 2. It was a trick question. They're both Type 2. Type 2 means as long as that VM is installed on an existing operating system, that's Type 2. So it doesn't matter how many hypervisors are installed on that VM, as long as on that machine, as long as they're installed on an pre-existing operating machine, it's Type 2. So I have 2 hypervisors, VMware and VirtualBox, installed on this my Linux machine. All right. Now, I want to show you. Now, if you wanted to set up a VM, a virtual machine, I have a Windows virtual machine running here. All right, let me power it on. This is a Flare VM, right? Yeah. Let me power this guy on and use it. So start. Now, before we got here, I obviously did the setup of the Windows VM. I created the VM. I added the Windows ISO file. I did this setup, installed, finished it, put in passwords, and now, I have this. I think I put in the password. Do I remember the password? Let me do a check. So I'm sure I didn't forget the password. Sorry, guys. Let me just check my books. I'm sure I did not forget the password. Very important. It would be disappointing if I don't have my password. For all the work put in. Let's do the malware analysis. So I'm pretty sure I have my password somewhere. Come on, where is this password? Did I snap it? Okay, so let me just, sorry guys, I'm just trying to get all my necessary credentials. But then this is the VM. Let's see. Oh yeah, I did snap it. Yes, I think I have it. Yeah, I have it. I have it. All right. So yeah, so it's taking quite some time to come up. I don't know why. But then this is a virtual machine. That's an example of a virtual machine. Now, what I wanted to show you, I don't know why it's here. I want to show you. Let me turn on there are two VMs I wanted to run at the same time. So let me turn on the other one. I hope this is the one that works. So there are two VMs I want to run at the same time. So I want to show them to you. Sorry, it's taking too long, and I do not understand why it's taking quite some time. If not, I started it a bit earlier. Okay, so anyways, before we get back here, right, while we give it time to load up, because I'll still come back here and show you just a couple of things. Just want to show you the way that you can actually, I don't know if it's working on Windows 10, but there are ways you can actually use the Windows to create a remote desktop access, remote connection to it, and it's part of the vulnerabilities that we can take advantage of, right? If you don't harden your computer. Then I'll also show you another way we can harden, and then we'll round off from there. But while we are getting it, right? While we are getting this, sorry guys, I don't know if you've seen this. It's a mess. I don't know what's going on. This key Flavian is not flaring. I really wanted to show this. Okay, so what about this guy? Okay, so well, as I said, I'll still get to show you this another time because it's slow up today. But then I still have something else I wanted to show you relating to endpoint and protecting your operating systems, right? Now, disclaimer, this is a free demo environment by one of the top or one of the big guys in cybersecurity, and they have a strong endpoint security solution and software that they sell. And so we can actually request for a demo environment using a business email. Actually, you can't just use an email, a business email, and they will provide it to you in seconds, right? So okay, it's okay now. This is okay. VM is not, if the VM is not working. I don't understand. All right, so they can provide it to you in seconds. So I'm going to share my screen and show that one, since at least I know that one is readily available. That was supposed to be the last guy I'll touch. Anyways, so when you see that screen, let me know. Nice. Can you see the screen sharing, guys?
Yes, we can see.
Great, great. So this is a way to enforce some level of security on your operating systems and your endpoint. Now, let me show you. Let me just give you a brief. I'm not going to go deep into it. I'm just going to give you a brief feel of what it looks like. Now, the platform. This is a demo platform. Should see some things. See, should be some things here that I can see. Right, this is a demo platform. Now, the demo platform is to a demo. It's showing you demo on endpoint protection. See it here, endpoint protection, and in endpoint protection, we're looking at from the angle of demo, operating system protection, and the rest of things like that, right? So, if we go into the dashboard of the endpoint protection, okay. Now, this is the dashboard of the endpoint protection of it on its own. Yeah, that we are loading. Okay. Now, uh, it's still loading. It's still loading. Let's see. Okay. All right. Perfect. Yeah. So that's it. So, yeah. So So now this is an example of some of the findings, right? Some recent threats. Now, this platform is showing you that this window, this device, Windows 10 laptop 2, right? There were some things that happened. Okay. There was a lockdown activity that happened. There was okay, I don't know. This is a hip protect activity. Let me see. Let me come in. Let me drill down here. So beautiful. So he's saying that okay, this is active computers. Let me see if I can see this report. Good, beautiful. There's a web threat that was blocked. Remember when I was giving you an example that a mail is sent, right? Someone clicks the malware or clicks a link. This is you saying that there was a web threat that was blocked. It's a malware. This is a malware, and the user is Bill.Atkins under the COP group, and they had a malware protection. That is what it's saying on this computer. I don't know if you get it. So it is like giving you, this is giving you report of what it's able to do, what it has seen, what it has done, how it has worked. Let me show you users. Let's see off this. So let's start with this. Beautiful. This will be better. This will be better. Great. So beautiful. So these are some of the servers, and these are some of the protection that's happening. We have antivirus on the server. This is a Linux server. An Ubuntu server, we have an antivirus on it. We have a server protection on this Ubuntu server as well, right? These are some of the policies that we can do on it. Then if I go to home, just come here. If I go to our home dashboard, let's see. If we go to our home dashboard, right? And see the total detections in general. It detected a total of 7 attempts or attacks in general, right? That's what it detected. Now, this is the platform that is helping protect your operating systems. But remember, as I said, it's not the first. It comes after you have done the things like hardening. And that's why I talked about CIS, because the CIS benchmarks would help you harden your endpoint to a certain level. Let that protection happen there. Before we now start thinking of, well, let's go to network, or let's go to this, or let's buy technologies. Well, that's how it works. These are some of the examples of ways that operating system security would happen in your environment. Okay, these are some of the ways it would certainly happen in your environment. So that is why you need to be very wary of this, and need to see that and understand how it works. Okay. So yeah, so basically let's give this some time to load again. While I think I can log into some other thing here. Okay, so it's loading. So it's loading. Sorry. Think. Okay, beautiful. Yeah, you can see some of the detections. Look at it. It found a threat, right? It found a command and control attack. Ooh, this brings up a good question. How many of us understand what the CNC means in cybersecurity? When I say, oh, there's a command and control attack, I'm saying, what do you think? What do I mean? Is there anybody that has an idea of what it stands for?
More like saying there's a threat. Yeah.
Yeah, but like, what exactly does it mean? When you hear, there's a command and control or CNC attack, what exactly is meant by that? Hmm? Is there anyone? Okay. Let me explain then. It's good it came up so I can get an opportunity to take you through. Now, CNC stands for command and control. Now, when an attacker or a hacker gets access to an environment, right? What we usually do, right, or what would be done is that the attacker would go and create or initiate. They will need to, because let's say I hack you, for example, I'll need to look for a way to manage that communication or connection between you and me. So I'll leave it open. So, for example, I'll hack you, and then I would want to still stay connected to you. And I want to control your devices from a central environment, right? And that is what CNC is, right? CNC in this space would it's like the process where an attacker has hacked you and is controlling you centrally. So there will be a constant connection between the hacked device and the attacker device. And that constant communication, there will be instructions sent from the hacker device. There will be payloads sent to your device. Basically, the attacker will own that device, and then there will be constant. It's like, if I own it, I need to have a way to communicate to it. So what happens in CNC is an attacker will take control. That's why they say he takes control, and then he starts commanding that device remotely. That is a CNC attack. So this is saying that we detected a CNC attack in the network. That we detected that it seems like an attacker has taken control of one device and is controlling and is commanding that device. Right now, the question is this: what do you think would be the first way, or the best way, or the fastest way to prevent, or to correct, or to react, or to respond to a CNC attack? Hmm?
Password.
Password. To respond to a CNC attack, the attack has already started happening. Are you sure password is the best way to go about it? So, are you sure? Password is the best way to go about it. Any other person can try, wants to try. Just think about it logically. Someone has to connect. You're hacked, an attacker over the internet. The attacker comes into your environment, takes control of one device, and then remotely through the internet, he's controlling that device or sending commands to that device. What do you think we can do when we notice it in reaction to prevent that CNC attack from continuing?
Because even if you turn off the system, the person already has access to it, right?
Yes, but point is, if you turn off the system, it's off now, so the person can't use it now. That's the point. The point, the person has hacked you, yes, but you cannot hack something that is not on. If I shut it down, it's shut down now. It's a physical switch off. But I'm not even looking at it from the angle of switching it off. I don't want to switch it off. We need to do our investigation and find out how that thing happened on that system. But what can we do at that moment to ensure that that hacker can't maintain that control on the device?
Antivirus can do nothing too.
And not the answer I'm looking for.
Okay.
Please, can you come again with your question?
Okay, so I said the question is simple. If an attacker has the command and control attack, he has taken control of the device and then he's sending commands over the internet on that device. Now we've discovered that, like, see, for example, our EDR solution has said, oh, see what's happening here. So we've discovered it, but we now want to do something to restrict it. So that we can now do our investigation to find out how it really happened. But we want to restrict, or we want to just do investigations, but we don't want the attacker to still be having that control and sending the commands that he has been doing. So what do you think is something we can do now to restrict the attacker from having that control or command
Is
over the
it
internet?
possible to change your password?
Changing password doesn't change anything. He has taken control already. That's the evidence I'm looking for.
Why do you find a way to block him from having access to you?
How?
By shutting down your access point, how he had access to that system.
He said by shutting down your what?
By disconnecting the access point he had to the system.
Yes, I'll take the answer. I will take the answer any day. Yes, I'm taking the answer. By restricting the access he has on my system. Now, what I will call it is, we call it quarantine. But all I just needed to hear from one of you was, let's never talk about quarantine. Just putting it in a separate environment. Just remove that. In fact, the best thing someone has said is remove that device from the network. Just remove network or internet on that device. The moment it
doesn't have access to your IP again.
He can't hit it anymore because it's no longer existing. Then you can now take your time and find out, how did this really happen? He did something. What did he do? Do you get it? Exactly. That's it. So yeah, that is how one of the things I wanted to hear from you. So now, it is something like this that would give you that information you need to hear. You understand? You'll be like, oh, this is what's happening here. These are the kind of things that are happening. For example, you have someone running a command and control in your environment, right? Um, you can see that this on that one saying that someone is trying to there's a data that was encrypted. There's an encrypted channel. There's another command and control, data evasion, defense evasion. That is, someone is evading an attack. This one is even scary. This one is saying that someone has encrypted your data. See it now. Someone has encrypted your data and it's giving you the information in detail. You understand? So that is how it works, and that's what this is all about. All right. So this is just one of the many ways, right? But I said the first way to attack or attempt to protect yourself on your infrastructure in times like this, the first thing you need to try and do is simple. Try and harden your environment. Ensure your environment is tight. Ensure your environment is difficult to penetrate. That's the first thing to do. Try and harden your environment. Very key. Once you have your environment hardened, it will not be easier to put technologies like this on top of it to enforce security. But remember, as I said, the reason why operating system security is very important, and why we spent like 2 hours just talking about it, and we're still going to spend another 2 hours talking about it very soon, is because one thing it achieves and what it tries to do for you is it is one scope that just needs to ensure it's secure. It's just one. You still have network, you still have applications, right? You still have people, but operating systems epitomizes your endpoint computers. How are you protecting the device users and the devices that you use? That is the message here. I don't know if it makes sense or if anyone here has any further questions. You have any further questions from anybody?
So what you're trying to say in essence is that once
Yes.
you discover that you've been attacked, while trying to find out what the issue is or how the attacker was able to get through to you, the first thing you do is to disconnect yourself
Oh,
from
yes.
being visible by the like the attacker. Yeah.
Exactly. That's the first
Okay.
thing to do. It's usually the recommended step. We call it quarantine. The moment you find a device that you feel has attacked, quarantine it. And if I go in quarantine it, the next thing you need to do is you need to now start looking at who. In fact, so what I would do normally, let me see if I can
Yeah.
see that information here. Let me share my screen again and see if I can find that information on this platform. What I would do normally is once I see the attack and I quarantine it and I tell my network team, okay, network team, please restrict this guy from other aspects of our network, right? But then that's not all. I would then start looking for who has this person been communicating with in the past few years. So let's. I don't know if you can see my screen again. Can you see my screen again? Hmm? Hello, please confirm, guys. Hello.
Yes, we can see your screen.
Oh, awesome. Thank you. Thank you so much. So I'm saying that, so let's say I see this information and I get this detail that someone is performing command and control. Let me try and see the raw data. Let's see. Why does it have the raw data for me? Okay, anyways, though. I'm seeing that the device in question, that creates device large number of model breaches, external ID 47.140 device 10.10.10.10.10 devices this equals to plugins org blah 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 blah. Okay, so the device in question that might be hit is a device with IP address 10.10.10.10.10, 10 in 4 places. Right now, I can then come and say, you know what, there with all these things, I want to do a bit of investigation. Right, so I go to my threat graphs and I look for device 10.10.10.10 And I'm like, device 10.10.10.10, where last have you been? Who have you spoken to in the past 5 minutes? Do you understand? That's the next question I'm asking. What has he been speaking to? Right? What has he been doing? So let's see if I can look at all the activities and see if any of them is related to 10.10.10. Let me even look at the device. Okay, computers. Looking for, you know, yeah, you know what? Well, you know what? Let's come here and look at all our devices. So I'm not seeing the IP addresses from here. I'm only seeing the device name, not device IP. So let me look for devices from here. So endpoints. Let me see computers. Let's see. I mean, I want to find the IP addresses. Once I find the IP addresses, so let's just try. Okay, it's loading. Okay, so see it. Now let me look for 10.10.10.10. Items are found. So I'm trying to, okay, so obviously it's not here. Let me see if it is a part of the servers. I'm trying to look for this. Okay, yeah, I've seen it. Let me see. Yeah, perfect. Let's see if 10.10.10.10 is there. What I'm trying to achieve is I want to see who has 10.10.10.10 been talking to in the past few hours or past few days. So let's say I hope it exists here, because how else really? So that means that's an old device and it's no longer in in. But let's try and go into one of these devices, right? Let's just look at one of them, right? Let's just do some. Okay. So see events. Good. Now see. This is where you come and look for it. This one is just communicating with me, so far it's not communicating with another person. How do you make sense out of this? Anyways, point is, this is what we will look for, right? We'll look for, we'll come in here, look at the events and start looking for what events are suspicious. Where did this guy talk to? Why we're doing it is, if we start seeing that this guy was trying to talk to any of that thing, we'll now go and start investigating the new thing, because what it means is, if that 10.10.10 is a hacked device and we have to quarantine it from our network, what it means is most likely those other people that he talked to frequently, either the hacker was trying to use the first hit to expand, yes, and continue hacking more devices in the network. I don't know if that makes sense to you. That's what I was trying to show you, but then these guys don't have IP addresses because it's demo environment, so they don't have like real life activity that I can take advantage of. Right? But yeah, that's what I'm just trying to see, right? So that's the first, when you find a hack, in quotes, right? The first thing you do, isolate, take it out of the network. The next thing you do is do an investigation. What happened? What did it do? Now, when you're doing an investigation, the minute you notice that there is a certain set of devices that it communicates with um, regularly, maybe there's a constant back and forth message between them. Those are the kind of people you need to see in terms of in terms of your network, in your infrastructure. So, okay, these and these assets are all communicating with this guy that we saw was hacked. Every asset that's communicating with the guy so hacked, you quarantine them as well. bring them out and investigate them. You find the root cause and find the problem. All right. I don't know if that makes sense. Okay. Awesome. All right. So, Nicholas, you're going to ask that question. I don't know if that gives you some clarity.
So
Yes.
there are better ways of making your findings without connecting back to the internet, because I
Yes, of
feel that
course.
once you're able to connect back to internet, the hacker like knows that you're back online.
Yeah, exactly. You don't need to connect back to the internet, right? You don't really need to. All you need to do is to do your findings, do your investigation, do your forensics. There's something called forensic investigation, for example. You do your forensic, do a drill down into all the things that's happened on that device, who is it communicating to, use your platforms like the SIEM and the endpoint solution I just showed you to do investigations and find out more.
So
You know,
all of
but
these applications or all of these things that you're using to do your findings, they don't need internet.
so that's the thing. These applications, it depends on how you implement them, though, right? If you've implemented them as an internal network thing, it might not need the application. If you implemented them as internet-based, right? Like the demo I showed you is internet-based. However, when you disconnect that device, that hacked device from the internet, right? The data, that's the information, the events, all the activities of that hacked device has already been uploaded to the platform and already been analyzed. Do you understand? So you're not losing anything. I don't know if you get.
Okay.
Exactly. So I don't know if any other person has any questions so far on operating system security. We are not done with operating system security, though. We'll come back and talk about hardening in our next session. And then I'll try to show you a few hardening techniques, like what I wanted to show you with the Windows Server, try to show you how to improve password and password security, and some password policies that you can implement on an Active Directory, as well as show you a few things that you might need to know about a Windows device and some of the weaknesses that are there, reasons why you need to harden it. All right. So I don't know if you have any further questions, and if not, I want to say thank you to everybody for joining this call, and I really appreciate the time and the engagement that I always get from everyone. All right. Thank you all, and enjoy the rest of your weekend.
Thank you, Kevin.
Thank you.
Thanks, guys. And yeah, just before you go, I might not be available. We might not have a class like this next week, Saturday. I think your training admins or coordinators would reach out to you guys in case that happens. You know, just I'm meant to go for a boot camp throughout next week, so I might not be available for this class because of the boot camp. But yeah, just saying, just in case. All right. Thanks, guys. Have a good one.